Hi everyone, welcome to Mathworld. This video is to discuss the Cambridge International AS and A-Level Mathematics Paper 6 Probability and Statistics 2 for October-November 2022, and the code is 9709/61. Alright, so let's move on to question 1. Question 1. The heights in meters of a random sample of 10 matured trees of a certain variety are given below. So you are given this 10 data. Find unbiased estimates of the population mean and variance of the heights of all matured trees of this variety. Okay, so now to get the unbiased estimates of the population mean, the formula is x bar equals to summation x over n. Alright, so now we need to get the summation x. Summation x is basically the sum of all the x here. Alright, so now from here I will just write my summation x equals to 5.9 plus 6.5 plus 6.7 plus 5.9 plus 6.9, so plus 6.0 plus 6.4 plus 6.2 plus 5.8 and lastly 5.8. So from here you will be getting 62.1. Okay, so from here I will just write it is same as 62.1 over the n will be 10 because it's given 10 over here. So therefore your population mean, the unbiased estimates of the population mean is 6.21. Alright, so now for the variance. So for variance we need to get the 1 over n minus 1. This is the formula, 1 over n minus 1, summation x squared minus square of summation x over n. So now we need to get the summation x squared. Alright, so from here, our summation x squared is basically square of all the x. So it becomes 5.9 squared plus 6.5 squared plus 6.7 squared. Just recalculate the previous value, but you need to square each of the x values. Plus 6.0 squared plus 6.4 squared plus 6.2 squared plus 5.8 squared plus another 5.8 squared. Okay, so from here, summation x squared is basically 387.05. Okay, so now substitute into the formula. 1 over your n minus 1 becomes 9. Summation x squared is 387.05 minus square of the summation x. Summation x is 62.1. Then you square it over 10 because the n is 10. Alright, so from here you will get 0.157 equal to 3 significant figures. So this is the solution for question 1. Alright, now question 2. A spinner has 5 sectors, each printed with a different color. Susma and Sanjay both wish to test whether the spinner is biased so that it lands on the red on fewer spins than it would if it were fair. Alright, so when it is biased means that the spinner will land on red section on fewer spins. So Susma spins the spinner 40 times. She finds that it lands on red exactly 4 times. Alright, so it means that this is fewer spin, right? Okay, so A, use a binomial distribution to carry out the test at 5% significant level. So now our H0 for binomial distribution or binomial hypothesis, H0, since this is fair, alright, it will be P equals to half, 0.5. And now we are testing, it's not 0.5. Okay, you have 5 sectors in a spinner. Alright, so each printed with different color. So now we are considering the red color. So supposedly your P will be 1 over 5 because you have 5 sectors, each sector with different color. So on the red it will be 1 out of 5. So you may write 1 out of 5 or you can just write 0.2. That is your P. Okay, now it says that here, okay, when Susma spin 40 times, right, it lands on red exactly 4 times. So from here, from this experiment, we know that it is less than 0.2. Alright, so it is not fair. So now alpha equals to 0.05. And for this, since we need to solve using binomial distribution, alright, so now before we do the calculation, we have to write down the criteria, the rejection criteria. Means that now we have to write reject H naught if the probability of x less equals to 4, this is a p-value less than 0.05. So we always reject H naught if the p-value is less than alpha value. Okay, so now when we do the calculation for binomial distribution, I will write down the distribution first. It is x is binomial distributed, the n is 40, and then the p is 0.2. Okay, so now we need to count what is px less equals to 4. So when px less equals to 4 and the x is binomial distributed, means that your x start from 0 and ends at 4. Alright? Oh, sorry, ends at 40. So now means x less equals to 4 means you calculate px equals to 0 plus px equals to 1 plus px equals to 2 until 4. Alright, so our formula for binomial is this. So if x is binomial distributed with mean and p, your px equals to small x, it will be ncx px qn minus x. Alright, so from here we need to apply the formula whereby your n is 40, your p is 0.2, which means I'll get 40c0. Right, so for information, the 40c0 is 1, so you do not need to write down. Then there's no success, that means the p power 0 is 1 as well, so I will just write down the q. So your p is 0.2 means that the q is 0.8, so I will get 0.8 to the power 40 failures, plus px equals to 1 means out of 40 there's only one success, so 40c1, then 0.2 probability of success, it is 1, and then probability of failures 0.8, and they are 39. Alright, so use this formula to get the next probability. And then when px equals to 3, you will get 40c3, 0.2 to the power of 3, 0.8 to the power of 37, plus px equals to 4 will be 40c4, 0.2 to the power of 4, and then 0.8 to the power of 36. Alright, so if you count all and get the sum, it will be 0.0759. So from here, you can write it is same as 0.0. Here no need to simplify because it's already three significant figures. Okay, so now once you have counted this value, then you compare with the alpha value, which is 0.05. So now obviously this value is greater than 0.05. So I will just write, since the probability of x less equals to small x less equals to 4, this probability is 0.0759, it is greater than 0.05. Therefore, do not reject H naught. Okay, so now our conclusion will be based on the question. So now your conclusion is you need to check whether it is biased or fair. Alright, so since we do not reject H naught, therefore we cannot say that it is biased. Alright, so you cannot conclude the p is less than 0.2. So now I will say there is insufficient evidence to conclude that the spinner is biased. Okay, so that's the solution for the part A. Hypothesis testing for binomial distribution. Okay, now Sanjay also spins the spinner 40 times. He finds that it lands on red R times. So B, use a binomial distribution to find the largest R that lies in the rejection region for the test at 5% significant level. Okay, so now your X is still same distribution, 40 and 0.2. Now, when rejection region means that the probability that X less equals to R is less than 0.05, because rejection region means that you reject H0. So we get the idea from the previous part. So over here, right? X less equals to 4, now you change the 4 to R. So now, since Px less equals to 4, just now we found 0.0759, and this value is greater than 0.05. Okay, means that now we cannot consider R as 4. We must consider the R which is less than 4. Alright, so we let R be 3. Let R be 3. So now Px less equals to 3, it will be same as, right, Px less equals to 4 minus Px equals to 4. So you do not need to count from 0 until 3. So you can just find this value less equals to 4 because we have found this. Then you just minus when it is equals to 4. It will be shorter working. So here will be 0.0759 minus, so when exactly 4, it will be 40 C4. Then the P is 0.2 power 4 and 0.8 to the power of 36. Alright, so from here, I will get 0.0284. So now you compare with the 0.05. Okay, so 0.0284 is less than 0.05. That means we are going to reject H0. So here, basically you can write reject H0 if. Okay, so here is less than 0.05. So since this is less than 0.05, that means it will be in the rejection region. Alright, so therefore the largest value of R, it will be 3. Okay, that's the B. Alright, question 3. Drops of water fall from a leaking tap at a constant average rate of 5.2 per minute. So this is the keyword. Per minute means that this is the interval. So whenever you are given the interval, this is Poisson distributed. Okay, so now this 5.2 is per minute. Now A, find the probability that at least 3 drops fall during a randomly chosen 30-second period. So this 5.2 is for 1 minute. Alright, so now we are looking at 30 seconds. So it means that if 1 minute is 5.2, alright, so 30 seconds, it will be half of 1 minute. So that means it's half of 5.2. Therefore, I will get 2.6. So from here, I will say that X is P Poisson, PO, 2.6. Alright, so now you need to count at least 3 drops fall during the 30-second period. So at least 3 means Px greater equals to 3. Now, for your information, for Poisson, X is Poisson lambda. The Px equals to small x, it will be E minus lambda x over x factorial. Okay, so that's the formula. So now, and then for the Poisson, the x start from 0, then continue until infinity. Okay, so due to that reason, if greater equals to 3 show that you means that you will not calculate from 3 to 3, 4, 5, 6, and so on, because you don't know when to stop. So we will use the complementation rule, which is 1 minus less than equals to or less than 3, okay, or less than equals to 2. So if less than 3 means that it will be from 0 until 2. Alright. So now use a formula. So you will notice that the E is in common, right? Because E minus lambda is a constant. So I will factorize the E negative 2.6 because your lambda now is 2.6. Then when x equals to 0, so here, based on the formula, the first one, the lambda power 0 will be 1. Okay, 0 over factorial is 1 as well. So I will just write 1 for the first term. Then when x equals to 1, I will just replace now. This is at lambda degree x. That means it's 2.6 power 1 over 1 factorial. No need to write. So just write 2.6. Then for the next one, you replace the x by 2. So I will get 2.6 squared over 2 factorial. Alright. So then when you calculate, this will be 0.482. That's the 3 significant figures for final answer. Alright, now B, use a suitable approximating distribution to find the probability that at least 650 drops fall during a randomly chosen 2-hour period. Okay, just now 1 minute is 5.2, right? So 1 minute will be 5.2. Now 2 hours. So 2 hours is basically 2 times 60 minutes. That means this is 120 minutes. Okay, so by 120 minutes, my lambda here, it will be 5.2 times 120. So now becomes 624. Okay, so we need to use the approximation because this value, this lambda, okay, I will write here lambda, is greater than 15. Alright, so lambda greater than 15, therefore you use normal approximation. So now, for Poisson, the mean is same as variance, which is 624. So now from here I will say that my y is Poisson 624. Since this is greater than 15, therefore we approximate using normal. So for the normal distribution, we need the mean and variance. So now again, the mean will be same as the mean from the Poisson. So the mean is 624, and same goes to the variance, also 624. Okay, so now you need to count the probability that at least 650 drops fall. So P, your y, at least 650 means that is greater or equals to 650. So remember, initially it was Poisson. Now you approximate it by using normal. Okay, so Poisson is discrete and normal is continuous. So two different types of random variable. Therefore, we need to consider the continuity correction. Okay, so for continuity correction means that you need to decide whether you plus 0.5 or minus 0.5 from the given value. So now your given value is 650. Let's say here is 650. Now, y greater or equals to 650 means that it could be exactly 650 and then followed by 651 and so on. All these will be your y values. But then now, since you are given 650, okay, so we have to consider two values. The first is less than, 0.5 less than 650, which is 649.5. Then the second one is 0.5 more than 650. So you'll be getting 650.5. Okay, so now I will change my working to PW greater than. We follow the symbol here. Here greater equals to, then you just write greater than. The equal sign is not important for continuous random variable. So from this number line, right? So you need to choose either more than 649.5 or more than 650.5 to include these two ticks. So obviously we need to choose 649.5. Right? So I will write PW more than 649.5. Then now we need to standardize the variable because your W is normally distributed. So P Z greater than 649.5 minus 624, that's a mean, over standard deviation. So standard deviation becomes square root of 624 because your 624 is the variance. Right? So now from here, when you do calculation, it will be PZ more than 1.021. So now we need to refer to the normal graph, symmetrical at the 0. At 0, okay, now 1.021 is on the right hand side. And then the region is greater than this line, 1.021. Therefore, it is on the right side, which is the upper tail. But then your table, the normal table, always shows you the region towards the left hand side. Therefore, in order to get the upper tail probability, it should be 1 minus the probability that z less than 1.021. So you will be getting this, right? Then now you can read PZ less than 1.021 from the normal table, and you will be getting 0.8463. Right? So now when you calculate, correct to 3 significant figures, it will be 0.154. So this is how we solve this question. Okay, so done this question, and the next one is question 4. Each month a company sells X kilograms of brown sugar and Y kilograms of white sugar, where X and Y have the independent distributions. The X is n 2500, and then the variance is 120 squared. And then the Y is normally distributed 3700, and then the variance is 130 squared. Now find the mean and standard deviation of the total amount of sugar that the company sells in 3 randomly chosen months. Okay, so now the mean is, okay, so since it is 3 months, we consider 3 months now, so it will be 3 of the total mean. So 2500 plus 3700. Alright, so you will get 18600. That is the mean for 3 months. Then now the variance, oh no, not variance, standard deviation. So standard deviation, it will be square root of the variance. So the variance will be 3 of total of the variance. Total of the variances. Right? Then here you calculate, it will be 306.43, and now you leave your answer equal to 3 significant figures, it will be 306. So this is how we solve for A. Now the company makes a profit of $1.50, okay, $1.50 per kilogram of brown sugar sold, and makes a loss of 20 cents per kilogram of white sugar sold. B. Find the probability that in a randomly chosen month, so now it's considered 1 month, the total profit is less than $3,000. Okay, so from here, we know that, let's say the total profit is 30. It will be 150 because this is a profit, 150 from the brown sugar. So just now in the question, the X is the brown sugar, okay, the Y is the white sugar. So I will write 1.50 X because it's a profit, that's why it's positive. And for the white sugar, which is a Y, it is a loss of 20 cents. So minus 0.20 Y. Alright, so from here, you need to find total profits. Since we know that X and Y are normally distributed, now we need to get the mean and variance for the T. So expected value for the T will be expected value of 1.5x minus 0.2 y. Okay, so from here it will be 1.5 EX. EX is 2,500, the mean. Okay, minus 0.2 EY. EY is going to be the mean for the Y, 3,700. So now your mean is 3010. Okay, then for the variance, so variance T, it will be, okay, variance of 1.5x minus 0.2y. But then according to the formula, okay, so we have a formula here. Variance ax plus minus by, it will be a square variance x, always plus, even though there is a minus here, plus b square variance y. Okay, so for this, I will write 1.5 squared variance x. So now your variance x is going to be 120 squared. So 120 squared, always plus, alright, even though it's minus here. So it will be 0.2 squared variance y. So your variance y is 130 squared. Then you will get 33076. So once you have obtained this, then I will just write my T is normally distributed. The mean is 3010, and then the variance is 33076. And now you need to count that the total profit is less than $3,000. So P, T less than 3,000. So now we need to standardize it because your T is normally distributed. So when you standardize, it will be 3,000 minus 3,010 over the square root of the variance, which is our standard deviation. Okay, so now you will get PZ less than negative 0.055. Once you get this, then you quickly refer to the graph, the normal graph. Middle value is 0. Then mark negative 0.055. And since it is less than that value, that means the region is on the left hand side. Now, firstly, we need to flip. Okay, so flip it to the positive part, it will be 0.055. And then the region will be the upper tail, which is the red color. So from here, I will say that it is same as PZ more than 0.055. That's your region. So to get this region, it is 1 minus PZ less than 0.055 because you are given the region, the less than region in the table. So here 1 minus PZ less than 0.055. And now read the value from the table. It will be 0.5219 for that probability. So when you calculate and correct to 3 significant figures, it will be 0.478. So that's the solution for this question. Right? Okay, next we move on to question 5. A builder's merchant sells stones of different sizes. A. The masses of size A stones have standard deviation 6 grams. The mean mass of the random sample of 200 size A stones is 45 grams. Alright, so that means this 200 is the N sample size. This 45 is the X bar. Okay, and then the 6 is the population standard deviation. Now, find a 95% confidence interval for the population mean mass of size A stones. So now I will write 95% confidence interval for population mean, which is a mu. So the formula is x bar plus minus z alpha over 2. Since the standard deviation, the population standard deviation is given, then it becomes sigma over square root n. Okay, now basically all the values are given. So x bar 45 plus minus. Alright, now for this 95%, you need to refer to the graph. Middle is 0. We know that it is 95% in the middle. This is 0.95. Then another 5% will shared by two parts, left and right side. So I know that each part will be 0.05 divided by 2. Then end up with 0.025. Now, you need to read the value from the table. Okay, when it says 0.975 here. So then from the table, you will notice that that is actually 1.96. Means that this line is negative 1.96. Okay, so here 1.96. So the sigma is given, which is 6. The n is 200. Now, this is a formula, and to get the lower limits for this confidence interval, we are counting using minus. So when you use minus, you will get 44.2, and the upper limit is counted using plus. So when it is plus, you'll be getting 45.8. So that's the confidence interval for the population mean. Right, now for B, the masses of size B, just now was A, now it's size B, stones have standard deviation of 11 grams. Using a random sample of size 200, that means n is 200, find n alpha percent confidence interval for the population mean mass is found to have width of 4 grams. Find alpha. Okay, now just for your information, let's say this is the confidence interval. Right? So now it's mentioned the width is 4 grams. That means here is 4 grams. The width is 4. And then we know that based on the formula, right, which is this, which is here. So this x bar plus minus this value, right, that will be the confidence interval, which means your x bar is in the middle. Okay, then plus minus z sigma over square root n. That means if it is minus z over sigma square root n, it will be here. This is the lower limit. This is x bar minus z sigma over square root n. This is upper limit. So here x bar plus z sigma over square root n, which means this part is sigma over square root n. Same for this part. Sorry, this is z. Okay, and same for this part. This part is going to be z sigma over square root n. Alright, so from here I know that each part is going to be 2 because your total width here is both, right? It's sum of these two, z sigma over square root n. Therefore, I will say z sigma over square root n is 2. Okay, so now sigma is given 11 grams, but then you do not know what is the alpha value. Therefore, the z will be unknown. So now I will just remain z alpha over 2 here. So now I will write z alpha over 2 multiplied by sigma is 11 and still 200 equals to 2. Okay, then from here, my z alpha over 2, it will be 2 times square root of 200, then divided by 11. And you will be getting 2.571. Okay, so this 2.571 is basically from the graph, the line over here. This is 2.571 and here is negative 2.571. Alright, so now you have to refer to the table. So from here, I need to find out when it is 2.571 here, what is the probability, right? So that this critical value is 2.571. So I will just read from the table. So from Z table, probability that Z less than 2.571 is 0.9949. Okay, I get it from the table. So now, which means here the total probabilities is 0.9949. So if here is 0.9949, that means this part is going to be 1 minus 0.9949. Alright, so I will get this is 0.0051. And you don't forget, the confidence interval means that the middle. Alright, so if the right hand side, the upper tail is 0.0051, which means this part is also 0.0051. Therefore, I will say PZ more than 2.571 is 0.0051. Okay, I have explained just now. And then now, alpha percent, because I know that here is 0.0051 and same for the upper tail, then the alpha percent will be the middle. So my alpha percent will be everything which is 1 minus these two parts, left and right side. So it will be 1 minus 2 times 0.0051, but then I need to get percentage, therefore I multiply by 100%. Okay, so, or probably you can just say it is 0.9949, right? Here, another option is, we know that the total, this plus left hand side is 0.9949. So if I want to find the middle, it will be just 0.9949 minus 0.0051. Then you will get the answer. Okay, I think that is better. So my alpha value will be just 0.9949 minus 0.0051, then I times 100%. Right? So for the previous step, you can write PZ more than 2.571 is 0.0051 and PZ less than negative 2.571 is 0.0051. No problem. So when you minus, you will get 0.98. Then you times 100%. At last, you will get 98.98%. So correct to 3 significant figures, it will be 90. Okay, check here. It will be 99.0. Okay, so this is how we find the alpha value. Right? Now, question 6. Given a graph, the diagram shows the graph of PDF, okay, probability density function, of a random variable x that takes values between -1 and 3 only. So from -1 to 3. It's given that the graph is symmetrical about the line x equals to 1. Here is symmetrical. How do we know symmetrical? Because it is in the middle. Alright. Between x equals to -1 and x equals to 3, the graph is a quadratic curve. So now, the random variable s is such that expected s is 2 times expected x. And the variance s is same as the variance x. Right? So expected is actually the mean. So from here, I know that mean s is 2 times of mean x. But the variance, no change. Variance is the spread measurement. Now A on the grid below, sketch a quadratic curve for the PDF of S. Alright, so now for your information, the mean is referring to the symmetrical line. So from here, right, from the graph, we know that mean of x equals to 1 because this is symmetrical at 1. Now, ES is 2EX. So ES is 2EX. That means becomes 2. So now I know that my symmetrical line of symmetry will be at x equals to 2. Okay, because of the mean. So x equals to 2 is my symmetrical line. And then for the variance, okay, so variance s equals to variance x means that this is a spread. So spread is referring to the shape. That means same shape. Alright. So now, or I would say that it will be same width as well. So same width. Okay, so now let's look at the original graph. We have done the symmetrical line. From 1 we change to 2. Okay, symmetrical line at 2. And then since the variance has same value, that means it must be same width. Okay, so now the width of the original graph, it is 2 units to the left and 2 units to the right. That means now your width for the new graph, the S, it will be the same, also 4 units. But then our symmetrical line is 2. Okay, so here 2 units, here is another 2 units, which means now your graph will start at 0 and at 4. Okay, to satisfy the same variance. Now, for the width, or for the height, okay, here height. So from here for the height, it will be the same. Okay, because it is same variance means that you will be getting same standard deviation. Standard deviation. Alright. So based on the original graph, here is 1, that means this is 0.5. Alright, so somewhere here, mid of this is 0.25. So mid of 0.25 and 0.5 is somewhere 0.375 when you calculate. So now I will use back. It is mid of 0.5 and 0.25. That means it's somewhere here. So now I will get this point. Okay, so what to do is my graph now becomes maximum point at 2, 0.35, 375, and then it touches the x-axis at 0 and 4. So this will be your quadratic curve. Alright. So this is your S. This is GS. Okay, done this part. Now, the random variable t is such that the mean of the t is same as mean of the x. Means that now, ET same as ES. So, the symmetrical line will be the same. So, symmetrical line will be at x equals to 1. Okay, then the variance here, variance t is 1 over 4 variance x. So variance t is 1 over 4 variance x. Now we need to check the standard deviation. So standard deviation t, it will be square root of standard deviation, square root of the right hand side, right? Because when you take square root, I would say this is square root. Square root variance t equals to square root of 1 over 4 variance x. So square root of variance t is basically standard deviation of t. So square root of 1 over 4, I will get half. This is standard deviation of x. Okay, so now be careful with this. So now, initially x equals to 1 is a symmetrical line. Okay, then when standard deviation of t equals to a standard deviation of half, that means now the spread, okay, of t is half. of the spread of S. So when you look at here, okay, the spread from the symmetrical line, sorry, not this, the original graph, the spread from the original graph, it is 2. Okay, the width is 4. The width is 4. Then the spread here is 2 from the symmetrical line. So from here I know that the spread is going to be half of 2. So now spread of t is half of 2, which means it's 1. Right? So which means instead of 2 units from the 2 units of the right hand side from the symmetrical line, and also 2 units from the on the left hand side from the symmetrical line, now becomes 1 unit because of half of the spread. So now if 1 units from the 1, it will stop at 2. So 1 units from the 1 for the left hand side, it will be 1. Okay, and then now you must understand that the area is still the same. So in order to get the same area, since now you have pushed the graph, okay, instead of total width is 4, now the total width becomes 2 only. So when you push the graph, right, that means the height will be increased. Okay, so the height will be increased by 2 times of the original height. So now from here, I know that my height of t is 2 times of height of x. Okay, because we need to get total of area is 1. Same area. So total area is 1. Alright, because we know that total properties is 1. So now when the height is 2 times of the original, means that now here is like, okay, when I refer to here, you are getting, this is 1.5. So now when you times 2, it becomes 3. So it will stop here. Right? So it will be 3 squares hang on please. So it means that, right, initially 1.5. So now you times 2, it becomes 3 squares. So now my height will be here. Okay, so from here I know that my height is 1, 2, 3. My height is going to be here. This will be my maximum point. So then I will get the graph, quadratic curve passes through these 3 points. So now let's sketch the quadratic curve. Alright, so this is your graph for the HT. Just draw a smooth quadratic curve. Alright, so this is how we solve these 2 questions. So remember, the variance, the standard deviation will give you the spread. Okay, and then we have to consider the height. Alright, so now C. It's now given that your fx equals to 3 over 2 times 3 plus 2x minus x squared, where the x defined from minus 1 to 3. And your fx equals to 0 otherwise, for other x values. Given that probability x between 1 minus a and 1 plus a is 0.5, show that a cubed minus 12a plus 8 equals to 0. So now, to get the probability, we need to do integration. So I will integrate 3 over 32. So since 3 over 32 is a constant, I will just take it out. Then I integrate from minus 1 to 3. Then, we are solving this, okay? probability. So your limits should be from 1 minus a to 1 plus a. So 1 minus a to 1 plus a. Then the function. So 3 plus 2x minus x squared dx equals to 0.5. So this is the calculation. The left hand side is the calculation for the probability. Now, this is a simple integration. So integrate 3 to get 3x. 2x becomes 2x squared over 2. That means it is x squared. Then the x squared becomes x cubed over 3. Limits will be 1 minus a to 1 plus a. Then equals to 0.5. Okay, so now you replace the x by upper limit. So 3 over 32. 3 bracket 1 plus a plus square of 1 plus a minus cube of 1 plus a, then divide by 3. Okay, then after that minus when the x is 1 minus a. So I will get 3 bracket 1 minus a plus 1 minus a squared, then minus 1 minus a cubed over 3. Close bracket equals to 0.5. Okay, so now we need to do expansion. So first of all, I will times the whole equation by 32 over 3. Then I do not need to write this on the left hand side. So left hand side will be 1. Then right hand side I just need to count what is the value. And at the same time I will do expansion. So here do expansion. So you will get 3 plus 3a. Then for the quadratic expansion, just use the formula. A plus b squared is a squared plus 2ab plus b squared. Alright, you will get 1 plus 2a plus a squared. Okay, then for the third one, you can just use the Pascal triangle, or you can say you can use the binomial expansion. So when it is a plus b degree 1, you will get the coefficients 1, 1. When it is degree 0, you get 1. Then when it is degree 2, I will get 1, 2, 1. When it is degree 3, okay, 1, 1. Then 1 plus 2 is 3. 2 plus 1 is 3. So these are the coefficients for the expansion. Therefore, the first coefficient is 1. So minus bracket 1. Now take out the 1 over 3. Okay, so I will write negative 1 over 3. Then expand cube of 1 plus a. Use this Pascal triangle formula. You will get 1 plus, the next coefficient is 3. So 3, 1 squared a plus 3. Actually, the first one should be 1 cube. Then 3, 1 a squared, because the next coefficient is 3 here. Lastly, coefficient is 1. Therefore, just a cube. Alright, so put a normal bracket. Then minus, do expansion over here. And then I will write okay, I just do expansion directly. So here will be 3 times 1 is 3, so minus 3. Then minus minus is a plus, so plus 3a. Then this minus times to the plus of the squared, so it will be negative. It will be negative. Then do expansion for the quadratic. It will be 1 minus 2a plus a squared. And then this minus times to negative 1 over 3. It becomes plus 1 over 3. And again, for this cubic, the power 3 of 1 minus a, use the same concept. Okay, for the Pascal triangle. So first coefficient is 1. Second coefficient is plus 3. Then it will be 1 to the power 2 minus a degree 1. Next, 3 bracket 1. Then minus 2 degree 2. Lastly, negative a degree 2, not minus 2. Negative a degree 3. Okay, then now when you multiply 32 over 3 by 0.5, you will be getting 16 over 3 on the right hand side. Okay, So now open all the brackets and do this and simplify the answer. So here I will get 3 plus 3a. Okay, then probably I can just simplify all this first. See here 3. Here is 1. So 4. I will write 4. Then the 3a plus 2a, it will be 5a. Then plus a squared. Then for this bracket, I will expand it. It will be negative 1 over 3. Then 1 plus 3a plus 3a squared plus a cube. Okay. Then minus 3 plus 3a. And then this minus times into the whole brackets. It will be minus 1 plus 2a minus a squared. And then this 1 over 3, I will keep it outside and multiply the terms inside the bracket. So be careful with this minus. Right? So my first term is 1. But the second term, because of the minus a, I will get minus 3a. Then the third term minus a squared, it becomes a squared. So a squared multiplied by 3, it will be plus 3a squared. Lastly, cube of minus a, it will be negative a cube. Then right hand side is 16 over 3. Okay, so now further simplify all the terms. See here, 4. This is minus 3, minus 1. So 4 minus 3 minus 1 means it is 0. Then now this negative 1 over 3 plus 1 over 3. That means you don't get any constant. Okay, so then for the 5a, here is 5a, and then 3a, 2a. So total now is 10a. And then when I do expansion for 1 over 3 and 3a, together with this, right, both are negative sign. So it means that I will be getting negative 2. Alright, so 5 plus 3a plus 2a is 10a. 10a minus 2a becomes 8a. Now for the a squared, here is my a squared. This is my minus a squared, means that already cancel off, no more a squared. But then when you do the expansion, this is negative 1a squared, right? And here is positive 1a squared, means that the a squared will be cancelled off. Okay, lastly, cube. So negative 1 over 3 times a cube will be negative 1 over 3 a cube. Okay, then here, this is also negative. So it means now I need to combine both, and I will get negative 2 over 3 a cube. Okay, right hand side remains as 16 over 3. So from here, I can times the whole equation. Okay, let's go back to the question. You need to show a cube. So the coefficient for a cube should be positive 1. Means that now I need to times the whole equation by negative 3 over 2. So that my a cube will be positive. I mean the coefficient for a cube will be positive 1. So when I multiply 8 by negative 8, I multiply 8 by negative 3 over 2, I will get negative 12. Okay, so negative 12a, then the next term is positive a cube, and then lastly, the last term is negative 8. So now I just need to rearrange to get the answer. Right, so I will get a cube minus 12a plus 8 equals to 0. So this is a solution for this question. Right? Now D, hence verify that the A lies between 0.69 and 0.6 and 0.70. So from here, right, you already form the equation in terms of A. So I will just let FA be the left hand side of the equation. This is my FA. And then I'm going to use the sign change rule to prove this or to verify this. So now F 0.69. It will be 0.69 cubed minus 12 times 0.69, then plus 8. So the value here is 0.0485, which is greater than 0. Next, F 0.70. It will be 0.70 cubed minus 12 of 0.70 plus 8. Okay, and then from here, I'm getting negative 0.057, so which is less than 0. So now I will write, since the first F is greater than 0 and the second F is less than 0, there's a sign change. Okay, hence alpha, or the A, is between 0.69 and 0.70. Alright, so that is the D for this question. Now question 7. In the past, Lakshmi time in minutes of her journey to college had mean 32.5 and standard deviation 3.1. That means this is a mu and this is 3.1 is sigma, population standard deviation. After a change in her route, Lakshmi wishes to test whether the mean time has decreased. She notes her journey times for a random sample of 50 journeys. So this is the N. And she finds that the sample mean is 31.8. That means this is the X bar. You should assume the standard deviation is unchanged. Alright. Carry out a hypothesis test at 8% significant level of whether Lakshmi mean journey time has decreased. Alright, so for this question, your H0 is mu equals to 32.5. You are testing whether it has decreased, so H1 is mu less than 32.5. Then the alpha is 0.08. Now, from this question, since your population standard deviation is given 3.1, regardless of the N, the sample size, it will be always normally distributed. Alright, so now I will draw the normal graph. The alpha is 0.08 and this is one tail test. It is lower tail. So your region is on the left hand side. So here is 0.08, here is 0. And now we need to flip to the right hand side because according to the Z table, you are given the value. The Z value must be positive. That means this part, the upper tail is going to be 0.08 and then the total region which is less than this green line, it will be 0.92. Okay, so now you read the table. When the probability is 0.92, the value, the critical value is 1.406. That means here is going to be 1.406. Alright, so now reject H0 if the calculated Z or the test value is less than negative 1.406. Okay, so now I will do the calculation over here. So your Z value is X bar minus mu over sigma over square root N. Alright, so now my X bar is given in the question 31.8. Minus this mu is the mu at the H0, which means it's 32.5. Over, and it's mentioned standard deviation unchanged. Alright, so we use 3.1, or we will just say we are using the population standard deviation instead of the sample. The N is going to be 50, the sample size. So when you calculate this value, it's going to be negative 1.60. Alright, three significant figures. So now negative 1.60 is inside the region. Therefore, our conclusion is reject H0. So you can write since Z is less than negative 1.460, reject H0. That's your conclusion. Sorry, this is your decision. Now your conclusion is based on whether Lakshmi mean journey time has decreased. So since we have rejected the H0, means that there is sufficient evidence to conclude that the mean journey time has decreased. Alright? So this is what I'm going to write to conclude that the population, we always refer to the population mean journey time has decreased. Alright, so that's the conclusion of this hypothesis testing. Alright, so now later Lakshmi carries out a similar test with the same hypothesis at 8% significant level using another random sample of size 50. Now B, given that the population mean is now 31.5. Find the probability of a type 2 error. Okay, so now the type 2 error is defined as H0 is false, but then we do not reject H0. Okay, that's the definition for type 2 error. So now we have to refer back from the previous part. We have stated here, reject H0 if the Z is less than negative 1.406. Alright, so I will write from part A, reject H0 if the Z is less than negative 1.406. Now, I need to count my A. Okay, so because I have no idea in what condition I do not reject H0. So now, my Z is going to be A minus 31.5 because your mean is 31.5. So over the standard deviation is still the same, over square root 50. Okay, so now from here, my Z is going to be negative 1.406. So negative 1.406. And what is my A? Right? So I need to find out what is the X, the region for the X, so that it will reject H0. So here, to A minus 32.1, sorry, this is, the mean is 31.5. Okay, so now, I'm not using 31.5 here. I will be using the previous one because in the beginning, we do not know in, the critical region, right? So I will use back 32.5 from the part A. After I have found the region, then only I use the 31.5 for the calculation. So here should be 32.5. Alright. So then over 3.1 divided by square root 50. So from here, your A is going to be 1.406 multiplied by 3.1 over square root 50 because you move up, and then the negative 32.5 will be moved to the other side, becomes plus 32.5. And now you are getting 31.88. So from here, I know that's my rejection region. So reject H0 if the X bar is less than 31.88. Okay, so now go back to the question here, we need to count the probability of type 2 error. So type 2 error means do not reject H0 when the H0 is false. So now, from this calculation, we know that reject H0 if the X bar less than 31.88, which means we do not reject H0 when it is greater than 31.88. So means that do not reject H0 if your X bar is greater than 31.88. Okay, so now my type 2 error probability becomes P X bar is greater than 31.88 because it is do not reject given that the H0 is wrong. So when the H0 is wrong, now my X bar is with the new distribution. So when you go back to the part 1 or part A, it's mentioned that your H0 mu equals to 32.5 is wrong. That's why now you are given the population mean is actually 31.5. Okay, so here I will write 31.5 and then my standard deviation is 3.1. Now I need to square it over 50 because now my sample size is 50. So now I need to count this probability. So P standardized X bar becomes Z greater than 31.88 minus 31.5 over the standard deviation. So which is square root of 3.1 squared over 50. Right. So from here, it will be P Z greater than 0.867. So when you found this greater than 0.867, now you quickly draw the graph. It is symmetrical at 0. Then let's say here is 0.867. The region is on the right side because it's greater than. So your table will not give you this value, but it will give you the value which is less than. Therefore, to get this shaded region or this probability, it will be 1 minus P Z less than 0.867. So now from the table, the probability will be 0.8070, and at last, you will be getting 0.193. Okay, so this question is quite tricky because you are not given the critical region. Alright, what is the condition for you to reject H0? That's why you need to calculate from the previous part. All these are from previous part. Alright, so okay, so we already come to the end of this video. Alright, again, thank you for watching my video. If you enjoy watching my video, please subscribe to my channel and wait for upcoming videos. Alright, thank you. Bye.